We'll make sure you have a worksheet. Maybe if you printed it out, or if you have it on your iPad or something. Okay, I will start at 205. For now, everyone can just chill first. You can have a look through the worksheet, and yeah, then you can see what we're going through today. Hi, hi, hi. Hi, everybody around the screen. Start 205. Okay. Okay, one more minute and we're going to start with everything. Okay, got a lot of people on YouTube as well. Hi, everyone on YouTube. YouTube got 78 people watching now. Hi, everyone. You guys can type in the YouTube chat as well. Hello. Okay, let's start. Okay, so for just to make sure, everyone just make sure to keep your mics muted the whole entire time. So today we're gonna go through organic chem, and you're gonna finally understand how to solve organic chem and how to score in organic chem. Okay, but first I have to go through this PDF. Hello, hello. Okay, so first of all, everyone on Google Meet, hi. Everyone on YouTube also, hi. If you guys need to ask any questions, please type in the chat. Don't worry, I will not judge you if you ask easy question or basic question or any other question. Basically, whatever it is, don't say. Okay, I'll make sure to attend to both sides. Okay, so first of all, I have to go through this PDF. Basically, who we are. Okay, so let me just introduce you to who we are and why are we even doing this crash course in the first place. Okay, we're Singapore's first fully online tuition center built for students who want real results and real support from the convenience of your own home. Okay, so on the right side, you can see over here, we are the largest upper sec community in Singapore. We got a lot of you guys in our community, and we're very grateful for you guys joining us on Telegram, on TikTok, on Instagram, all this. Okay, so we are 5 young tutors who specialize in online classes. Okay, we've been teaching tuition for a long time, and this year we just started teaching online full time. So who not too long ago have been through the O-level grind just like you. Can you enlarge the screen? Okay, on YouTube, sadly, it's just how it is. But on YouTube itself, you can actually zoom in. Okay, so we are 5 young tutors. Not so long ago, we just went through the O levels. Okay, first thing I want to ask you guys in the chat, can you guys, just from my camera, can you guys guess how old I am? Okay, just put out any guess. How old do you guys think I am? 50. Thank you. 19, 22, 27. Let's see the YouTube side. 20, 23, 23, 23. Okay, yeah, around there, around there. Okay, so I'm actually 21 this year. So I'll be going uni. All our tutors are my age as well. Okay, so we're very, very young. We are not like your school teachers. So if you want to ask any questions, don't feel paiseh. We understand who you are. Okay, so we've made it to top universities such as Cambridge, NUS, LSE, and King's London. So these are some quite good universities. So we'll show you how to do the same. And so again, if any questions, please do just type in the chat and I'll attend to everyone. Okay, next one, our resources. Get our go-to learning resources to excel in your studies. Okay, so if you're an active member in our Telegram chat, you probably have seen some of our cheat sheets, some of our notes, and stuff like that. So if you like that, you would love being a student of us because we have these kind of very nice looking and very concise worksheets and notes every single week. Okay, so once you're a student, you'll get weekly curated worksheets and notes, coded cheat sheets and summaries, 24/7 WhatsApp support. And because we are fully online, you also can get recordings if you ever miss a lesson or you just want to revise anything. Okay, and also you get weighted assessment revisions and review packs for all the important exams. Okay, So our results, 2 in 3, last year, 2 in 3 of our students achieved an A1 at the O levels. So Dojo students go on to attend top schools. These are just some testimonials if you want to read. Okay, very, very nice words. I'm not the best at taking compliments, but it's very nice words from my past students. And yeah, so a lot of them were able to get A1. And these are just some random fun text from my WhatsApp. So sure, I got A1. Thank you so much. All this stuff, very, very cute. Okay, so all of them, at the end of the day, right, these results are not because of some secret method or some secret formula lah. We just put in a lot of hard work, and we, as tutors, we just give them the correct direction to put in the hard work. That's gonna be me. Yes, that's gonna be you. Okay, so these are just some fun facts, and these are our tutors. You probably have seen Ryan and Henry before if you came for the bio or the physics crash courses. This is me. I'm going NUS next month, or next month. Okay, lastly, this is our schedule. So currently for combined Chem Sec 4 is on Tuesday 7 to 9, and Pure Chem Sec 4 is on 7 to 9 p.m. on Sundays. Okay, so these are subject to change and subject to add new classes if there's a lot of people who want to join, just to let you guys know. Okay, all classes are held on Google Meet. And lastly, this we have affordable pricing because we are fully online. We can afford to charge a lot less than other centers. So only $6 per 2-hour lesson, $60 I mean. And yeah, so that's what you get. Okay, so any questions, guys, before we actually start with the crash course today? Oh, wait, no, sorry. One more thing. Poll time. Okay, basically, last month we were at Sengkang MRT giving out booklets, like physical booklets. For example, the Chem and Physics definition booklets, Math, Mensuration and Graph booklets, and situational writing booklets for English lah. So we actually got a lot left over. And yeah, we want to go to other MRTs. So I thought since everybody is here, right, might as well I just do a poll and see which one you guys want to do. So let me just put up the poll right now. Which MRT next? Theme. Okay, let me just put in the poll. I'll do it for Google Meet, and I'll do it for YouTube as well. Okay, so I put up the poll. You guys can access it at the bottom right, and then let me just have a look. Okay, I'll show you guys the results as it's going. Serangoon, Yishun, Bedok. Okay, about a few more seconds and I'll close it and I'll have a look. The goat. I'm sorry, bro. You're the only one. You're the only one spamming Pungo. Okay, so as you can see, Serangoon won, followed by Jurong East, and then Tampines, and then Yishun. Okay, but spoiler alert, I just wanted to do this just for fun. We're actually going to be coming to all 4 MRTs. Woo! We're going to be coming to all 4 MRTs. The schedule will be coming out soon. Okay, so the schedule will be coming out soon. I'll see you guys very, very soon. Okay, I just wanted to do the pool to just see. Okay, so that's about it before our actual class itself. Okay. Hey, YouTube. Then come Punggol, please, my life server and my code. Okay, we will talk about it. I'll talk to the team about it. Okay. If not, let's all refer to the actual worksheet for today. Okay, guys. Hopefully you guys printed it out or you have it on your iPad or something, because we're going to be going through this for now. Okay, so this is our emergency crash course. First of all, I just want to talk a bit about how to chemistry. And before that, I want to give you guys a reminder that your first actual written paper for O levels is actually exactly 118 days away. So if you're lazy to do the math, that's less than 4 months. So if you guys haven't logged in yet, if you guys haven't started studying and properly revising yet, then yeah, please do. We only got 118 days left before your actual O levels. Okay, so for these 2 hours, please just focus up and we can cover a lot of ground in organic. Okay, so first of all, how to chemistry. This is just some general advice that I wanted to give to all of you. So first of all, I want you guys to understand something called the 70-30 principle. Okay, what that means, right, is that generally 70% of all questions in your O levels are for chem will be fundamental knowledge-based questions. So for example, these will be like definition questions, properties questions, state and explain kind of questions. Okay, so these will be 70% of your marks. Whereas the other 30% will be higher level application-based questions. Okay, so why is this important? It's because you think about it, if 70% of my entire grade is based on fundamental questions, right? Then if I can have a solid fundamental base for every single topic, then you will put yourself in good position to score an A. Okay, so what that means, right, is you should prioritize being decent at every single topic rather than being like super damn pro at a few topics and then you don't know anything for the other topics. Okay. Okay, then my second tip, just generally, is that if you take one thing away from today, please understand that MCQs are the greatest way to practice these 70% questions, especially if you're F9 to B3 student. Okay, meaning if you're not already excelling, right, my advice is to spam MCQs as much as possible. And the goat of all goats is your topical DYS MCQ. Okay, so if you do this over and over and over again, 100% you will improve as long as you go check your mistakes and then see what's wrong. Okay. Okay, so if not, for now, this is it before we move on to the actual organic chem. If you guys are ready to tackle organic chem, can you put a thumbs up in the chat? Spam the thumbs up like this. Boom, boom, boom. Okay. Thank you, the goat on YouTube. Okay, first of all, first thing I want to cover, this is your organic tier list. Okay, so if you guys don't have this worksheet printed out, I would recommend you screenshot this. This is basically a tier list of all the different topics that are in organic chem. Okay, so the S tier means it's the most important, A tier means it's still important, B tier is that it's not so important. So you should structure your revision based on this tier list. So you should prioritize the S tier ones. So as you can see today, what we'll be covering is the homologous series stuff, the alkene stuff, and the cracking stuff. Okay, so for S tier, you got esterification, which is only for pure. You got homologous series, you got bromine tests, you got condensation, polymerization. Okay, in your A tier, you have biofuels, you have cracking, oxidation, and addition polymerization. For B tier, you have your free radical sub, your isomerism, and your fermentation. Okay, so again, you should prioritize the ones on the S tier before the A tier. Okay, so you can take a screenshot of this if you want. Today, we are covering these three topics, homologous series, alkenes, as well as your cracking concepts. Okay, so if not, with every worksheet that we give, it comes with a definitions sheet. So these are all your definitions necessary for organic chem. And over here at the bottom, condensation polymerization is start because, as you can see, it's only for pure chem. Okay, so these are very, very important. Just make sure you have most of these in your head. Okay, other than that, we have also the cheat sheets for your reactions. Okay, so for organic, I want you guys to think of it as your reaction side. You have your signature reactions, meaning reactions that only, for example, alkanes, alkenes, carboxylic acids, or alcohols can undergo. Okay, so these are their signature reactions. Each kind of homologous series will have their own signature reaction. Okay, then the other type of reactions is your between functional groups reactions, meaning that you can turn an alkene into an alkane, or you can turn an alkene into a polymer, or you can turn an alkene into an alcohol, into a carboxylic acid. Okay, so this is the way that I want you guys to think about reactions rather than memorizing them based on a topic by topic basis, you kind of want to have a map in your head such that questions will be easy once you actually memorize. Okay, still got some people coming in now. Okay, so as you can see, if you guys want to refer to this, you want to screenshot this, please check the bottom left because it's either for pure or for combined. Okay, so if you're pure, you're combined, you have different reactions that you must remember. Okay, any questions so far? Sure, is isomerism and free radical sub in combined science? Yes, free radical sub is under your alkanes, isomerism also. So only the first topic is pure. It's only esterification and addition polymerization, which is pure. The rest is all combined as well. Okay, let's move on. What do you say about signature reactions again? For signature reactions, it just means that these are the reactions that alkanes, alkenes, carboxylic acids, and alcohols only they can undergo. Okay, so signature meaning that is their personal signature reaction. Okay, so these are very important, always tested. Okay, so let's actually start off with the basics of organic. I want you guys to actually have a good understanding of the fundamentals. If not, you'll be very, very confused. Okay, so if you look at this first page, this is page 9. We're talking about hydrocarbons. Okay, so hydrocarbons are compounds that literally contain only hydrogen and carbon. Okay, please listen carefully because a lot of people have this fundamental concept gap. Okay, you're going to see them a lot over the next few topics as they are the baseline of organic chem. So once again, these guys contain only hydrogen and carbon. Okay, last year, even until prelims time, a lot of my Sec 4s were making this careless mistake, right? Only hydrogen and carbon. Okay, so let's look at this first test. Are these guys hydrocarbons? Okay, circle those that are. Okay, I'll give you guys 1 minute, think about it, and circle the ones that are hydrocarbon out of these 4. Okay, so hopefully you guys were able to notice that only the first 2 are hydrocarbons. Okay, why are only the first 2 are hydrocarbons? Because this one got oxygen, and then this one got oxygen also. Okay, so again, hydrocarbons only contain hydrogen and carbon. So please be very careful about this one. Very, very easy, careless mistake to make. Okay. Okay, so like I said, hydrocarbons are like your baseline of organic chem. So if you look at the next page, we're talking about this thing called a functional group. Okay, so again, this one, a lot of people have a lot of misunderstandings of functional group. So a functional group is the group of atoms responsible for the characteristic reactions of a particular compound. Okay, a lot of words, but basically, it's the part of the molecule that gives it a special power or a special flavor. Okay, so in organic chem, everything other than your regular C and H chain is usually a functional group. Okay, so this analogy is my favorite analogy in the whole world. If you think of organic chem like a yogurt, okay, you go eat Yole, you go eat Yao Yao. They'll always give you the baseline white color yogurt first, right? The standard flavor yogurt. Then you can choose your toppings, you can add your fruits, you can add your sauce, you can add your chocolate. Okay, so how this relates to organic chem is that your hydrocarbons are like your baseline yogurt, whereas your functional group is what determines the flavor and is what differentiates the yogurt from other people. Okay, so if you ever forget or you're confused about this idea, just think back to the Yole and Yao Yao. Okay, so again, everything other than your regular C and H chain is probably a functional group. Okay. Okay, if you guys understood so far, please try this one. Circle the functional groups in these compounds if they are available. Yeah, I'll give you guys 30 seconds to try this one. Circle the functional group. So again, anything other than the C and H chain, the standard C and H chain is probably a functional group. What's the difference between a substituent group and a functional group? Okay, a functional group in our syllabus, right, is actually basically stuff that we learned already. So our alcohol group, our carboxylic acid group, stuff like that. Okay, a substituent group in your syllabus, you don't need to know the exact difference, is just something that doesn't have a name. For example, a random bromine group, a random chlorine group, a random anything group lah. Okay, so functional groups actually will change the identity of the organic compound. So if I have a OH functional group, I'm called an alcohol. But if I have the substituent groups, it doesn't actually change my identity. Okay, so for the practice here, the functional groups are the OH group and the COOH group here. Okay, please check that you guys circled this one. How to know which one is a functional group? Basically, is everything other than your regular C and H chain. Anything other than your carbon and your hydrogen. Okay, any more questions before I move on? So if it contains anything other than a C and H, it contains a functional group. Yeah, you can understand it like that for now. Then when we move on, then you'll get a better understanding. No worries. Sure, must we remember the IUPAC name? That one I'll get to later. Okay, so now that we know, right, that our hydrocarbon is like our baseline yogurt, and our functional group is like the toppings on top that give it the flavor. Now we can move on to the next kind of idea, which is your homologous series. Okay, that's how you pronounce it, homologous series. So homologous series in simple terms are, before I get to the words here, you can think of it like a family. Okay, so we got different families. Maybe in Singapore, we got like the Lim family, the Tan family, we got the Smith family, all these different families. So each different homologous series is a different family. Okay, so a homologous series is a family of compounds with the same functional group, same general formula, and similar chemical properties. Okay, basically, right, they have the same functional group, they have some kind of pattern in formula, and they got basically similar vibes. Okay, so another very, very, very commonly misunderstood idea is your idea of general formula. Okay, so a general formula, the definition is a formula that represents a homologous series of compounds using letters and numbers. Okay, this one is the definition tested a lot, not really. But I just want to explain to you guys the idea of a general formula. Okay, so if we look at the bottom left of page 11, we have a homologous series. So this is what a homologous series looks like. So again, it's a family of compounds with the same pattern, the same vibes. So for this case, you have C2H4, you have C3H6, you have C4H8, you have C5H10, and so on and so forth. So what do you notice about what kind of pattern can you spot in the formula? Okay, think about the ratios between the carbons and the hydrogens. Okay, I'll give you guys a bit of time to think. Okay, what you'll realize, right, is that the carbon to hydrogen ratio is always 1:2. Okay, 2:4. The next one is 3:6. Next one is 4:8, and so on and so forth. So for this homologous series, right, his general formula is CnH2n. CnH2n. What that means is that if I substitute in any value of n, so let's say n equals to 2, I'll get C2H4, which you can see is the first member of the series. Then if I sub in n equals to 3, I'll get C3H6, and then I'll get the next member of the series. Okay, so that's the idea of a general formula. If anyone is confused about this, can you give me a thumbs down in the chat? Okay, good. Seems like everyone can understand. Then let's just do a quick practice. What's the general formula for this next homologous series? Okay, so you can use the same kind of thought process as we just used. The first one is CH3, C2H6, C3H9, C4H12. Okay, Brian, thank you. Correct. Yeah, just give everyone on YouTube a bit of time to think also. Sure, is that empirical formula? No, empirical formula is a different thing. This is your general formula. But I understand it's very similar. How many homologous series are there? For you to know, you need to know 4 different types of homologous series. The general formula must always contain the functional group. Yes, if there is a functional group in the homologous series, then the general formula must always contain it. Okay, yeah, so correct. Thank you, everyone. Here, your homologous series general formula is CnH3n. Yep, good, everyone. Okay, Reina asks, is alkane a homologous series? Because you said homologous series have the same functional group, but alkanes don't have functional group. Yes, correct. So generally, they have the same functional group. So for alkanes, is I guess a special, a special exception because it doesn't have lah. So the same thing among them is that they don't have one, if you get what I mean. Yep, so those who said CnH3n, you are correct. Okay, so why is the idea of a homologous series so important? It's because for your under your organic, you have a few different topics. You got your alkanes, you got your alkenes, you got your alcohols, and you got your carboxylic acid. So these are your main 4 topics. So what you realize, right, is that each of them is you're literally just studying 4 different types of homologous series, like 4 different homologous series. So if you don't have the understanding of a homologous series, what it is, then you are super duper cooked for the rest of the topics. That's why a lot of people just struggle understanding everything because you don't have the foundation here. Okay, so that's why we're going through this idea of a homologous series. So again, a homologous series is like a family. So you can think of alkanes as one family, let's say the Tan family. Then the alkenes is like a Lim family, the alcohols are a Smith family, so on and so forth. So we're just studying 4 different families. Okay, what's the difference between empirical formula and general formula? Later I'll go through that one. So alkane is not a homologous. Alkane is a homologous series. All 4 of these are homologous series. Okay, any more questions before I move on? Okay, then let's move on to page 12, which is just some extra notes and properties about a homologous series. Okay, so all of this is referring to any kind of homologous series. So these properties all apply, apply to all four chapters: alkanes, alkenes, alcohols, and carboxylic acids. Okay, so they really, really apply to all four chapters. They give you a bit of time to copy down. Sure, is arene tested? No, it's not tested. So alkane is a homologous series, but with just with no functional group. Yeah, exactly. Okay, so let me just talk about this for a sec. Compounds in the same homologous series, again, homologous series, you can think of it as a family, right? So if I'm in one of the families, for example, I'm an alkane, I'm in an alkane family, or I'm in an alkene family, the compounds within those families will share the same functional group or no functional group if they don't have, differ by CH2 between each member, have similar chemical properties, and show gradual trends in physical properties. So what you can think of them is, again, like a family, or they are all siblings with one another. Okay, they all have the same surname, which is their functional group. They all have around the same height and weight, which are your physical properties. And they all got similar personalities, which is your chemical properties. Okay, so the understanding of the idea of a homologous series is legit super duper important. And yeah, if you don't have this idea, you are screwed for everything else. Okay, yeah, so a lot of you guys asking about alkanes. Like I said just now, you can think of alkanes in this case as legit just your base yogurt. Okay, that's why they're your first topic, because they're very, very similar. I mean, very, very simple. They're just your basic yogurt with carbon and hydrogen only. They don't have any other functional group. Okay, then alkenes and alcohols and carboxylic acid is where you add on the flavors and the toppings. Okay, any more questions? Okay, here at the bottom here, this is your property list, and it actually applies to each one of these four chapters. So if you thought that you have to memorize the properties individually, no, you don't, because these properties and the highly tested properties are similar among all four chapters. Okay, so boiling and melting point, as you go down the group, it increases. Viscosity, as you go down the group, it increases. And then flammability decreases down the group. So down the group means down the homologous series as you get bigger. Okay, so just one thing I want to take note over here. The idea of viscosity is something that a lot of students don't really understand, and that hence they cannot explain well. Okay, so viscosity is actually a very simple concept. Is the idea of thickness in a liquid. Okay, so if you think about today, this morning, you wake up and then you boil your water and then you make some hot Milo. Okay, think about it. If you put a lot of powder in the Milo, then your Milo is going to become damn thick and damn sludgy, right? It's going to be super duper thick. And yeah, so compare this against maybe a glass of water. Your Milo, your super thick Milo is considered more viscous or has a higher viscosity. Okay, so make sure you understand this idea. Is it volatility another property? Yes, volatility is another property, is later down in the worksheet. Will you be sending the annotated PDF? Yes. Yeah, volatility is later in the worksheet. I'll show you. Okay, so one hack to remember the properties are down the group, everything, all properties increase except for flammability. Okay, flammability is the only one that decreases. Okay, so that's just one small little hack to remember. Okay, so if we scroll down here, this is just a 2 questions test to see whether you have listened so far and you have understood so far. Okay, so if we look at question 18, the formulae of 3 different compounds are shown. Which statement about these compounds is correct? Okay, so we got 3 different hydrocarbons here, and A, they have different general formula, B, and so on and so forth. Okay, so I'm going to be putting up the poll on Google Meet, and again, it's on the bottom right of your screen. And if you, once you're done, please vote in the poll. Then we can see how well everyone has attempted this question. Okay, let's try. It should take about 1 or 2 minutes only. For the YouTube side, give me 1 second. Let me try do the poll. Okay, so this one, please be very tedious when you're reading through and be careful. If viscosity increases down the group, it will get thicker. Yes, exactly. So it will become thicker. Okay, YouTube side, I put up the poll already. Okay, about 30 more seconds, I will go through. Hi, I joined late. Has the basic concepts of organic chem been gone through? Yes. If you want, you can go onto the YouTube, then you can just scroll back. Okay, but later I'll recap it a little bit also. No worries. Okay, guys, let's look at the polls. Okay, out of 50 that voted in the Google Meet, 38 of you guys able to get A. Okay, so the correct answer here is actually A. So if you're able to get A, I want to say good job because it means you know your basics. So let's look at each option. On on YouTube, about 80% or so can get A. Okay, good. So for A, they have different general formula. In this case, for hydrocarbons, we only have 2 general formulas we need to know. So if you have gone through alkanes with your school before, you have seen CnH2n plus 2. And the other one is CnH2n. Okay, so these are the only 2 possible general formulas. So let's call this 1 and 2. For the first compound over here, this guy has a general formula of CnH2n plus 2, right? Because it's C2H4 plus 2. Okay, any questions, please do ask. For the second option is your general formula CnH2n. And then for the third option is CnH2n plus 2. Okay, so what you will see is that this statement is correct. They have different general formula. Okay, so quite a few put B. Is actually the second most popular option. B says their chemical properties are similar. Okay, in this case, Chemical properties are similar when your compounds are part of the same homologous series. Same homologous. Okay, meaning that same family lah. So if you remember back, what does it take to be in the same homologous series? You must be in the same, you must have the same general formula. Okay, so if they have different general formulas, they cannot be in the same homologous series, meaning they cannot have similar chemical properties. Okay, so same thing with your physical properties it's basically the same reasoning. And then lastly, they are members of the same homologous series. In this case, it's also the same reasoning. They have different general formulas, so they cannot be part of the same homologous series. Okay, if you understand so far this question, can you give me a thumbs up in the Google Meet? Let's see. Let's go, guys. Okay, good, 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 good. Okay, I'll give you guys a bit of time to copy down this if you want. Okay, Rainer. Yeah, let me know what you don't get, and I'll explain your question. I mean, your answer. Yeah, I'll answer your question. I don't get option B. Okay, for option B, basically, if you look back at the page behind here, members of the same homologous series have similar chemical properties. Okay, so you want to go see, right, whether these three compounds are they in the same homologous series. Okay, so what you'll notice is that they have different general formulas. So therefore, they cannot be in the same homologous series. So therefore, they cannot have similar chemical properties. Why do they have different formula? Because basically the pattern between the C and the H is different. So for this one, it has general formula CnH2n plus 2. Second one has the general formula CnH2n. What are a part of the homologous series? Is it the carbons and hydrogens? Yes. So everything is part of the homologous series. All right, I got it. Okay, Ken. So let's look at question 38 for the basics. So checking again, did you listen to what I said just now? Let's try and apply the hack that I explained to you guys. So alkanes are a homologous series of organic compounds. So which row describes the physical properties correctly as the number of carbon atoms increases? Okay, so first of all, think about it. If your number of carbon atoms increases, are you going down or are you going up the homologous series? Okay, so let's try this. I'll put up the poll right now. Question 38. Oh, oops. Are we supposed to derive the formulas or just need to remember? For the general formulas, there's four that you need to remember, which are the four functional groups, I mean the four homologous series that we learn. Sometimes the questions will give you a new general formula that you need to derive, but it will always be not too confusing one. So don't worry. Yeah, you need to remember the four though. Okay, for 38, here, if you remember what I said just now, as you go down the group, every property increases except for flammability. Okay, again, every property increases except for flammability, which is the opposite. So in this case, as you go down the group, your viscosity should increase, your melting point should increase, and your flammability should decrease. Answer here is B. Okay, so on Google Meet, most of you able to get it. On YouTube, same thing. What's the main difference for pure and combined for this topic? Pure has a few differences. Your alcohols and carboxylic acids is different. You have a new idea of esters, which combined don't need. And then for polymers, there's a different type of polymer that you need to know for pure. Yeah, but for alkenes and alkanes, it's exactly the same. So don't worry. Okay, good. So it seems like most of you listen, most of you understand so far. Okay, so let me know if you have any questions. If not, I will move on now. Okay, so before we move on to the alkenes part of today, I just want to give you this important alert. In every organic chem topic, there are 3 things you must know. Okay, so whenever you think of organic chem, you want to think of it like this. There are 3 things you must know. For example, for alkanes, you need to know why they are unique. You need to know their properties, and you also need to know their reactions. Okay. So whenever you're studying or you're trying to revise for these topics, please make sure you have these in mind so that you can structure a revision properly. Okay, and so that you know whether you actually revise fully or not. Okay. So like as mentioned just now, today we are going through alkenes, not alkanes. We are going through alkenes because it's very, very important. Okay. Okay, so to understand alkenes, you have to understand this idea of saturation. So carbon has a electronic configuration of 2,4. Okay, just stick with me for now, guys. If you haven't learned organic in school, just stick with me for now. It can form a maximum of 4 single bonds. Okay, so this is the maximum for carbon. 1, 2, 3, 4. 4 single bonds. For example, hydrogen, 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 hydrogen. Okay, so the analogy that you need to remember so that you can memorize this and never forget this. Imagine next year, all of you guys are at JC orientation or you guys are at poly orientation. Okay, and you bring 4 fruit tips. So hopefully you guys try this sweet before. It's like my favorite sweet ever. Okay, if you guys imagine you bring 4 fruit tips and then you give to 4 different people. Okay, if you can give out all 4, you have made 4 friends and you have saturated your number of friends you can make. Meaning you have maximized the number of friends you can make. So once again, if you give 4 to 4 different people, 1 to each person, you have saturated the number of friends you can make. So that's the maximum number of friends you can make. Okay, so why this relates to carbon, right? Is because in the same way, if carbon gives out 4 single bonds, it's also known as saturated. Okay, so what is unsaturated? So in this case, imagine you have 4 fruit tips, but if you're a girl, you like this guy a lot, he damn handsome. So you give him 2 fruit tips. Or if you're a guy, you like this girl a lot, you give her 2 fruit tips. So that would be the equivalent of a double bond. Okay, so in a double bond, now if I'm double bonded, I can only make 3 new friends because I gave 2 fruit tips to 1 person. So I only left 2 fruit tips to give out to 2 more people. So again, the idea here is if you have a double bond, if you give 2 to 1 person, is unsaturated. If you give 2 fruit tips to 1 person, you wasted it and you are unsaturated. Because you could have made 4 friends, but you only make 3 friends. Maybe the guy like you back, but at the end of the day, you only make 3 friends. For alkenes, what happens if there's only 1 carbon atom? Okay, that's a good question. Alkenes, actually, there's no such thing as methane or a 1 carbon alkene. Yeah, it doesn't exist. Okay, so if we look at the definitions here, the whole point of this, right, is to explain to you the idea of a saturated versus unsaturated hydrocarbon. So a saturated compound is a compound containing only single bonds. A hydrocarbon is a compound that contains only carbon and hydrogen. Okay, so this definition is always tested. If you combine these two into one definition, it's a saturated hydrocarbon. So a hydrocarbon that only contains single bonds. Okay, so it will look something like this. So these are your alkanes. But we're not covering that today. What we are covering is the unsaturated hydrocarbon. So basically, it's a hydrocarbon that contains one or more double bonds. So it's only saturated if there's 4 bonds, then if there's 3 bonds. Adriel, you shouldn't think of it as 3 bonds. You should think of it as if there is a double bond, then it's unsaturated. Because it can only bond to 3 other things. Get any more questions, please type in the chat. So again, all of this is very important, right? Because if you don't understand this stuff, and then you go blindly memorize the reactions and then the properties and stuff, you will be super confused, which is why a lot of you guys are attending this crash course, because you guys didn't do it the correct way. And in school, your teachers never teach you the correct way.
Hi Jojo,
Hi.
I wanna ask, what are the homologous series that you need to know?
The homologous series that you need to know.
Yeah,
there's 4. There's the alkanes, there's your alkenes, there's your alcohols, and then your carboxylic acids. So these 4 are the homologous series you need to know, and these are 4 the 4 topics that you learn.
Okay, thank you.
No worries. Can I say unsaturated hydrocarbon haven't achieved electronic configuration? No. Okay, that's not correct. Because an unsaturated hydrocarbon does still achieve electronic configuration. Okay, this is just a small little thing. If you guys don't understand the idea of single bond, a single bond is where you share 1 electron each, for example. Okay, a double bond is where you share 2 electrons each. Okay, so it's the same if you have 2 single bonds versus you have 1 double bond. You actually will have the same electronic configuration. Okay, if not, let's finally move on to this part, which is did you listen part 2. Okay, so these 2 are very, very common and very, very, very easy to make careless. So please try 5. Which structural formula represents a unsaturated hydrocarbon? Okay, so try and recall what does it mean to be unsaturated. Try and recall what does it mean to be a hydrocarbon. Okay, let me put up the poll right now. I'll put it up on YouTube also. Okay, I'll give you guys about 1 or 2 minutes to try this one. Let's go. Unsaturated hydrocarbon. Be careful with this one. This question's only for pure. Today, everything is for both pure and combined. Yeah, so for combined chem students, everything today is related to you also. You need to know everything. Okay, so for question 5, unsaturated means you have 1 or more double bonds. Okay, a hydrocarbon means you only contain Remember, it's easy to remember because it's literally in the name. Hydrocarbon. It only contains hydrogen and carbon. Okay, so if we look at A, does it have a double bond? Yes, highlighted in yellow. Does it only contain hydrogen and carbon? Yes. So the answer here is A. For the other options, they all have double bond, but they all include something other than a carbon and a hydrogen. Okay, so that's why answer here is A. Okay. If no questions, we can try two. If any questions can still ask. Let's look at two. Similar kind of question. In this case, a little bit different. Okay, so this one just be tedious. The structure of compound J is shown. Which row describes J? Okay, saturated hydrocarbon. Let's try this. Okay, J is on the right side, by the way. Okay, the pole is up. So saturated hydrocarbons need to have only hydrogen and carbon too. No, okay, I'll explain back later the idea of saturated again. Okay, the structure of compound J is shown. Which one describes J? If you look at J, is it a hydrocarbon? Remember, hydrocarbon means only hydrogen and carbon. Okay, for saturated, it means only single bonds. So again, now the difference between saturated and unsaturated is saturated only contains single bonds, unsaturated has a double bond. Okay, so this question is a bit tricky and not super duper well done because they actually separate the answers into saturated and hydrocarbon. So for saturated, actually it is saturated because it only contains single bonds. But in this case, it is not a hydrocarbon because it has a oxygen here. Okay, so over here the answer will be C. Okay, only 70% able to get C. Yeah, Bobo fish, this is correct. Thank you. Accident. Yep, so this one, if you put A, you put D, you probably read the question wrongly. In this case, it's different requirements. So they're saying, is it saturated, yes or no? Is it hydrocarbon, yes or no? Okay, so this style of question, please be very careful. A lot of times come out in MCQ. Okay, any other questions? Okay, if you guys understand 5 and 2, even if you didn't get it correct, as long as you understand my explanation, right, then you are actually okay already for the basics. Okay, so again, what have we gone through so far? We've gone through all the basics of an organic compound that a lot of you guys miss out. Okay, even if your school went through the entire organic chapter already, a lot of people still have these foundational issues. So that's why you still find it difficult to score an organic chem and understand the questions. Okay, so like I explained just now, we have in our organic syllabus, we got your Tan family, we got your Lim family, we got a Smith family. So today, other than the basics, we're also going to be tackling one of the families. Okay, so in this case, is your alkenes. So if we go back down to page number 17. Okay, everyone, let's go to page 17. Can it be unsaturated if the bond is between other elements? Yes, can. So it just needs to have a double bond. If it has double bond, it's straight away unsaturated. If the double bond is between, yeah, that's considered unsaturated. Okay, so let's all look at page 17. The whole point of me explaining the idea of unsaturated versus saturated is so that you understand alkenes fully. So alkenes are unsaturated hydrocarbons with general formula CnH2n. Okay, so again, this is our example of a homologous series. So this is honestly the most highly tested homologous series and one of the more important ones. Okay, so each alkene molecule has at least a CC double bond, at least one. Why? Because they are unsaturated. That's the whole point. Okay, again, it's unique because of the double bond. If it has more than one CC double bond, it's considered polyunsaturated. Okay, polyunsaturated. So how do you remember this? Poly means like, the last time I said it was like poly means like polytechnic. So at a polytechnic, you got a lot of techniques. Like you can take like engineering, you can take communications, you can take banking, right? So poly means you have multiple. Unsaturated means double bond. Okay, so sometimes they will test this in exams. They will ask you, explain the meaning of polyunsaturated. Just need to say it has more than one double bond. Okay, so again, the overarching concept of homologous series is very important to understand alkenes as well, right? So if we look at this table, this is our alkenes homologous series. As you can see, like I said, it's like a family, right? So they all look quite similar. As like I said just now, they all have the double bond. Somehow, they have a double bond. And all of their formulas follow the same CnH2n general formula. Okay, so for this one, as you can see, like we explained just now, when who was it? When Brian asked. Yeah, just now Brian asked, what happens if there's only one carbon? As you can see, there's no such thing as a one carbon alkene, right? Because to be an alkene, you must have a CC double bond. So if you only have one carbon, then you cannot have a CC double bond. So this is a commonly asked question. Why is there no such thing as methane? Could you repeat the limb family part? Okay, sure. The idea is that homologous series is like a family, right? So what does it mean? It means like they have the same functional group, they have the same general formula, they have similar chemical properties. So our example of this for today's lesson is our alkanes homologous series here. Okay, so again, for organic chapters, we must always know why are they unique, what are their properties, and what are their reactions. Okay, so based on this, you should be able to answer why are alkenes unique. Alkenes are unique because they have CC double bond. Okay, so that's the understanding you need to have so far. Okay, so if you have not gone through alkenes or alkanes in school yet, which is quite alarming, but that's your own school's thing. If you haven't gone through this in school yet, you might be wondering, why on the left side we have these names. Are we supposed to know these names? Okay, so for those who have already learned this, just stick with me for a second. Let me explain this to the rest. Basically, right, there is a easy to remember formula to be able to get the name of any organic compound. Okay, if we look at the next page on naming, the naming comes from a prefix and a suffix. So as you can see, the prefix is based on the number of carbons. So if you have 2 carbons, your eth, you have 3 carbons, your prop, you have 4 carbons, your but, so on and so forth. Okay, so in the syllabus guide itself, they do say that it's only you only need to memorize up to butene, but I recommend you just memorize pentene and heptene also, because it's just easier lah. If not, you might get confused in the future. Okay, it's up to you. Okay, then the suffix part, it depends on what homologous series you're in. So again, the prefix is the number of carbons, the suffix is the homologous series. Okay, so again, you can think of it like your first name, maybe like Ryan, and then your suffix, which is like your surname. So it's like Ryan Lim. Oh, yeah, that's the idea here. Okay, so if you guys understand this, can we try do this quick practice? Okay, if let's say I gave you a 4-carbon alkene, can you quickly type in the chat what's the name of this alkene? 4-carbon alkene. What's the name of this alkene? Okay, yeah, correct. Okay, this is butene because but is 4, ene is alkene. Okay, so it's really important to know this and to not forget this. Okay, any questions before we move on? Okay, good. Everyone on YouTube is butene. Okay, so now we know why they are unique. Okay, they got your double bonds. Okay, they are unsaturated hydrocarbons. Therefore, they are unique. So this is the unique thing about this homologous series. Okay, so like I showed just now, what's the next thing that we need to know? Now we need to know what are the properties. Okay, so let's look at page number 19, which goes through the properties. So again, properties you memorize once, and you memorize finish already. Okay, because it's basically the same for all your different homologous series, all your different families. Okay, over here, I won't go through too much because it's just memory work. Again, the tip I have for you guys is that everything increases down the group except for flammability. And so again, this one is really just memory work. Just memorize this one time, you memorize it forever already. Okay, one more time. Every property goes up as you go down the group except for flammability. CR7 says, will you be going through alcohol and carboxylic acids? Sadly, we cannot go through that today. We will be covering that in the weekly classes. How about carboxylic? Are they unsaturated? Yes, because the C double bond O. So technically it's unsaturated. Okay, so now we have tackled. What have we tackled? We have tackled why are they unique? Double bond. We have tackled the properties. Everything increases except for flammability. Okay, so we are 2/3 done with alkenes. Yay! Yay! Okay. So what's left? Reactions. Okay, so reactions are generally a lot of people find the most challenging part of organic. But if you follow our map again, you will be able to do it with no problem. Okay, so last part is reactions before we move on to see whether you understand. Okay, so alkenes are unique. They have a signature reaction. So once again, each one of your homologous series, right, has a signature reaction. For alkenes case, is known as addition. Okay, so is exactly what it sounds like. You're literally adding something onto the alkene. Okay, but it's not as easy as it sounds because we have three different types of addition, which we need to go through today. Okay, so let's look at the first one. It's called hydrogenation. So this is the addition of hydrogen. Okay, so again, for all reactions, you need to know the reactants, you need to know the conditions. So to add hydrogen onto alkenes, you must have a nickel catalyst at 200 degrees Celsius. Okay, so what you'll notice here in the reaction itself is the double bond. I will highlight it in pink. The double bond turns into a single bond. Okay, so this is called your reaction mechanism. Okay, basically what is happening in the reaction. So whenever you add something, whenever alkenes undergo addition, they always break the double bond. Okay, once they break the double bond, the other atoms have space to be added onto the alkenes. Okay, so as you can see, these H atoms are literally added directly onto the alkene. And then what you'll notice, right, is this guy has double bond on the left, the one on the right doesn't have. This is an alkene, this is an alkane. This reaction is damn cool because you can turn an alkene into an alkane. Whoa. So through hydrogenation, you can convert alkenes into alkanes. That's the importance of this reaction. Okay, anybody confused? Can you give me a thumbs down? I can re-explain. Okay, Angeline, don't worry. Basically here, right, addition is exactly like how it sounds. You're adding something onto an alkene. So remember, this is a reaction that alkene can undergo. So in this case, you're adding hydrogen, H2, onto the alkene. So what happens is that your double bond on the alkene breaks, and then your hydrogen is being added on to the alkene itself. Will they ever ask you to draw what I just drew? Never. Yeah, but that's just understanding. I don't understand the example on the margarine one. For margarine, that one is just like, honestly, right? I'll be very, very honest with all of you guys watching here, right? This margarine thing here, you just need to memorize. You don't need to understand. Okay, basically, margarine is just a saturated compound. And if it undergoes hydrogenation, it becomes a vegetable oil. So this is just an example of hydrogenation reaction. Yeah, you don't need to know the formula of margarine or vegetable oils, just the words. So, okay, Beehive says, so when it undergoes addition reaction, the double bond is always broken. Yes, exactly. If it undergoes addition, double bond always broken. Can alkanes convert to alkenes? Okay, good question. What you want to refer to is actually the map here. Okay, at the front here, the map, there's only a reaction that goes from alkenes to alkanes. Okay, that is not the other way around. Okay, so no. No worries. Okay, so far, if you look back at this map, we already have covered this first reaction. Okay, woohoo, first reaction covered. So if they ever want you to change an alkene into an alkane, now you know what to write. Okay, Everyone? Okay, if you're ready to move on, can you give me a thumbs up in Google Meet? My dream football. What does it mean to be unsaturated? Like, what do they do? It's not really about what they do. It's just a property lah. I thought alkanes to alkenes is cracking. Okay, that one is a different kind of idea. Later I'll show you. But basically that map is like a one-to-one. Like you change this to that. Alkanes, I mean cracking is different really. Okay, let's move on. Okay, so again, this next one is called bromination. So it's also addition, but in this case, you're adding on Br2. Okay, bromine. Why is there a star here? Because this exact reaction is legit tested every single year. I promise you it's tested every single year. If you go look at TYS, somewhere, either in the MCQ or in the paper 2, it'll be tested somewhere. Okay, so for this one, as you can see, same exact mechanism. My double bond breaks, my bromine gets added onto the hydrocarbon. Okay, exact same thing, it's just that you change the atom. Okay, this one, your condition is just aqueous bromine. Okay, so you might be wondering, why is this so important? Okay, this is actually our distinguishing test between alkanes versus alkenes. Okay, distinguishing test. If you ever want to, if you ever have two things that you don't know which one is alkane and which one is alkene, you always use bromination. Bromination. So addition of bromine to test. Okay, so this one I just give a quick explanation. If you guys remember your halogens chapter, your periodic table chapter, bromine exists as a reddish brown solution. Okay, if you guys, hopefully you guys remember this, it exists as a reddish brown solution. So if you react with the alkene, the bromine itself is actually added onto the alkene. So one more time, the bromine itself is added onto the alkene. Therefore, there's no more bromine in the solution, and therefore the solution will turn colorless. Okay, red to colorless. Okay, so I just yapped all of that to say, right, that when you add the alkene to bromine, this reaction will occur and the reddish brown solution will turn colorless. Hydrogenation is non-reversible. Yeah, it's non-reversible. Is bromination only for pure? No, it's for combined also. Okay, everything today is for both pure and combined. No worries. Okay, so again, let me just draw this out for you guys. If you react with alkene, your bromine solution will go from red to colorless. However, if you react this bromine with an alkane, no reaction will occur. Why? Because if you know your alkanes chapter, there is no such reaction as this. Okay, so this is your distinguishing test. If you react it with an alkene, it will turn colorless. If you react it with an alkane, it will stay reddish brown. So this is how we distinguish between alkenes and alkanes. Can repeat for bromination, sure. So the mechanism is exactly the same. You break the alkene's double bond, and then you add on the bromine atoms onto the hydrocarbon itself. Okay, so these alkenes can react with bromine, but alkanes cannot. So that's why we use it as a distinguishing test. Okay, any other questions before I move on? Okay, so we've actually tackled the first two types of addition reaction. Okay, so if we look at the next page, our last type of addition reaction is called our hydration. Okay, so this is the addition of steam. If you forgot, steam is just H2O lah. Okay, so same exact thing. It should be getting annoying now that it's literally the same thing. Here, your H2O, right? The atoms are added onto the hydrocarbon. But in this case, you just need to take note that the atoms are H and OH. Okay, so two different atoms. Okay, so the importance of this particular reaction is that if your school has covered this already, you should recognize this OH group. Okay, this is called your hydroxyl functional group, which is for alcohols. Alcohols contain this. So this is turning an alkene into an alcohol. Okay, again, the conditions you must memorize, but I won't go through that today because it's just memory work. What's 60 atm? 60 atm is the pressure. ATM is atmospheres. That's like a unit for pressure. Okay. Okay, so if we look back here, let's look back at the cheat sheet again, the reactions map. What have we covered? We have covered bromination, right? Now everyone knows that you add aqueous bromine, then you break the double bond, becomes colorless. Okay, what else have we covered? How to turn an alkene into an alkane. We've also covered how to turn an alkene into an alcohol. So you can see the alkene is a very, very, very important chapter. It covers so much of all the things we need to know. Okay.
Hi Dojo, could
Hi.
you repeat for the alkane part again?
Which part? The alkene part.
The hydrogenation.
Oh, the hydrogenation. Okay, can. Hydrogenation is the addition of H2. Basically, for all addition reactions, you break the CC double bond, and then you add on the other atoms. So for hydrogenation's case, you're adding on the hydrogen. I'll highlight in yellow. This hydrogen is just being added onto the carbon chain. Okay, so same thing with this and this. Okay, for hydration, it's just a bit unique because instead of adding on two of the same atom, you add on one OH and you add on one H. Okay, so moving on, if there's one singular careless mistake that I can say is the number one most common careless mistake for alkenes in the whole entire world, is this next part called the placement of addition atoms. Okay, this one is super duper important. I literally see this every single year. Okay, this careless mistake every single year. Just now when I explained, right, I told you that you break the double bond and then you add the atoms onto the alkene. Okay, but what I didn't specify was the placement of the atoms itself. The addition atoms, in this case Br2, are always added onto the carbons that share the double bond. Meaning in this case is these two yellow carbons. Oh, I careless here. Wait, I made this one should be a single bond. See, is hydrogenation non-reversible? All of them are non-reversible. Okay, so once again, the atoms in addition are always added onto only the carbons that share the double bond. Please do not make careless, and then instead of putting the bromines here, you go add the bromine onto the last carbon. that makes no sense because you're only supposed to add it onto the carbons that share the double bond. Okay, so please do not make this careless mistake. Okay, so just a quick test before we move on. Let's say we have this alkene. So give it 1 second of thought and think about it. What is this alkene called? Everybody just think, don't need to type in the chat, just think. This is propene. 3 carbons and alkene. Okay, so if we were to add, let's say, H2O onto this propene, can you guys take 1 minute and draw out the end product here? Okay, what would it look like? Let's try this one. Same thing, you break the double bond and you add the atoms on top. Okay, I'll be back in 1 minute. I need to go get water. Okay, I am back. Can I put it on top instead of below? Okay, let me show you first. So this correct answer here would look something like this. So 3 carbons, the number of carbons stayed the same. Again, you only add the atoms in which on the 2 carbons that the double bond is on. So these 2 carbons here. So what would it look like? H everywhere. And then you have your H and OH added on. Okay, so can I put it on the top instead of below? Can. No worries. It's the same thing. Okay, so hopefully all of you guys were able to get this. Anybody have any questions? Okay, if not, let's move on to actual prelim questions. Okay, these next 2 questions are actually from prelims. If you're able to get this, you've listened the past 1 hour plus, you can solve these prelim questions. Okay, let's look at question number 9. The diagram below shows an apparatus used to test a gas. Okay, so what they tell you, here you add a gas to bromine, aqueous bromine, bromine solution. Okay, if the bromine solution becomes colorless, what is the structure of the gas? Okay, let's try this one. This one should be quite quick. Let me put up the poll. Why is it OH? What if I put OH in the middle carbon? Also is okay. Yeah, OH in the middle carbon is fine. Just either of the 2. Why is it OH? Because this is the hydration reaction. Okay, let's try question 9. Let's go. Yeah, I'll explain it a bit. I'll re-explain a bit.
Wait, Joe, can you go back to the one with the water later? The one with the protein and the water.
Sure, can. I'll just show you on the screen now. Okay, so for that one, the placement of the addition atoms, again, you just want to add on the new atoms onto the carbons that had the double bond. Okay, the addition atoms are always added onto the carbons that share the double bond. Okay, about 30 more seconds and I'll go through question 9. Why is it OH for hydration? It's just it's the same structure as this one. Basically, you add on H2O, you get a H and you get a OH on one atom and the other atom combined. So it's just the memorization of the addition, the reaction itself. Okay, let's go through question 9. Okay, question 9 again. What reaction is this? Bromine solution turning colorless. This is your bromination. Okay, this is your bromination reaction, which is this one. Okay, so like I explained just now, if it turns from reddish brown to colorless, it's an alkene. If it stays the same, it's an alkane. Okay, so let's look here. If it became colorless, it has to be an alkene. And therefore here, the gas is C, because it's the only one with a double bond, and therefore a alkene. Shaktao, all right, I got it. Okay, good. Okay, anybody still confused about question 9? Can you give me a thumbs down? Again, if the solution turns colorless, it has to be an alkene. Okay, about 70% able to get C. That's good. Okay, last question for this part, question 10. Okay, so again, this is a real prelim question. So if you were able to get 9, very, very good job. For 10, which compound undergoes an addition reaction with bromine? Okay, so this one, not only you have to figure out which is the compound, you have to use another way to figure out. It's not just, they don't just show you the double one. Okay, so let's try question 10 now. This one is about the same concept, but a little bit harder. Okay, let's try 10. I put up the poll. Let's go. Okay, let me show you guys the results. In this case, the answer is A. Okay, let me explain why is it A. First of all, addition reaction with bromine, like I said, only alkenes can undergo this. So once again, is the alkenes signature reaction, meaning only alkenes can undergo this. Okay, so immediately we should look at C and D with these functional groups over here and realize that these ones cannot. Okay, because this one has some random functional group here, you don't need to know yet. If you haven't learned, this one also has another functional group. So it's not a unsaturated hydrocarbon. Remember, alkenes are your unsaturated hydrocarbons. Okay, so the question here now is between A and B. So how do we differentiate A and B now? One of them is an alkane, one of them is an alkene. You must use your general formula. So remember, for alkenes, my general formula is CnH2n, which corresponds to option A. So again, if you're one of the 80% who was able to get question 10, you have understood so far. Good job. Okay, on the right path. Any more questions for this question 10? Isn't A an alkane? Nope. B is an alkane because B has CnH2n plus 2 general formula. A is CnH2n. So that's how you differentiate between the alkene and alkane. Yeah. No worries, no worries. Okay, before we move on, I just want to explain to you, if you look at the bottom, we have real prelim questions here. And as you can see, they test very similar stuff, but there's one more piece of concept you must know to be able to try these and to be able to do this. Okay, so I promise you guys, if you have listened so far and you listen to this cracking one, you don't need to worry about alkenes already. Okay, because you will confirm understand. Okay, this last concept is called cracking. Okay, last time when I explained it to my students, right, everybody start laughing, they think cracking quite funny. Okay, fine. Catalytic cracking is the proper name. Catalytic cracking is a process where a long chain hydrocarbon from petroleum is broken down into shorter chain hydrocarbons in the presence of a catalyst. Okay, so if you guys remember what's a catalyst, it's basically just something that speeds up the reaction. So the catalyst thing is in the name, that's why it's called catalytic cracking. Okay, so why do we undergo this process of taking a long chain hydrocarbon and turning it into a small chain? Is because smaller chain alkanes and alkenes are more useful than longer chain alkanes. Can you go back to the... Okay, I will go back to that in a bit. Later, I'll let you guys copy. Let me just go through this one first. Don't worry, that one I'll show you later. Okay, just listen to this one first so that you can follow along. Okay, so for this one, this is an example of a cracking. As you can see, you take a long chain hydrocarbon and you break it down into smaller chain hydrocarbons. So the conditions here, like I said, exactly the same. Not exactly the same. Same thing you need to just memorize. Usually the products would be an alkane and an alkene, as you can see here. If there's ever different kind of products, you would the question would tell you lah. Okay, so if you listen to that so far, if you understand that so far, this is the most important concept that is always tested. If my on both sides of the equation, meaning my long chain versus my two shorter chain, on both sides are the number of carbons and the number of hydrogens must be the same. Meaning, if I started off with, let's say, C10H22, then my resultant products must add up to C10H22. So for example, maybe C5H10 plus C5H12. Okay, what I mean is that the number of carbons on the left and on the right must always be the same, no matter what. Okay, please remember this. If you don't remember this, you will get every single question wrong, I promise you. And so the number of carbons and hydrogens equals to the number of carbon and hydrogens. Basically to say that you don't lose any atoms in this reaction. What happens is you have the same number of atoms on both sides. Is this process reversible? No. Okay, so once again, at the end of the day, it's really just taking a long chain hydrocarbon and breaking it down into two smaller chain hydrocarbons. And the number of carbon and hydrogen on both sides is exactly the same. What's the signature reaction by alkane? It's called substitution. Free radical substitution is is on the cheat sheet lah. You can read about it. Okay, if you guys understand that, last few MCQs for this before we move on to the real stuff. We might run a bit longer than 4 p.m., but hope you guys stick around. For this one, question 3. The cracking of 1 mole of X. This one I start because it's not easy. The cracking of 1 mole of X produces 2 moles of ethene, 2 moles of propene, and 1 mole of propane. Okay, so just for your info, I will write down over here the formulas just to make it a bit faster. Okay, so how many carbons does 1 molecule of X contain? Okay, so if you understood this idea over here, that the number of carbons and hydrogens on the starting compound must be equal to the ending compounds, then can you try question 3 and try and form, my hint is to try and form an equation. Okay, I'm putting up the poll now. Let's try this one. Question number 3. This one is not the easiest. If you're able to do this, good job. Okay, let's try this. Okay, this one I'll give you guys about 2 minutes in, a bit longer. In this case, to solve this question, you need to, like I said, create a chemical equation. So over here, I have 1 mole of X turning into ethene, propene, and propane. Okay, the important thing here is to note that they said 1 mole of X produces 2 moles of ethene, 2 moles of propene, and 1 mole of propane. So why is this important? Because you always, here this is where you apply your mole ratio. So your prefix here should be 2, your prefix here should be 2, and then the other ones should be 1 and 1. Okay, because 1 mole, 2 mole, 2 mole, 1 mole. Okay, so why this is important is because now when you calculate, like I said, number of carbon and hydrogen on the left and the right must be equal. This one here, this is 4 carbons, 8 hydrogens. This one is 6 carbons, 12 hydrogens. This one is 3 carbons, 8 hydrogens. When you add it together, you get C13. Here, your number of carbons is actually C13 carbon atoms. Okay. Any questions? Ask away, ask away. YouTube, does cracking have to start with an alkane or can alkanes be cracked too? It's usually alkanes. Okay, any questions? Google me anything. Don't need to balance equation. What do you mean by balance equation? In this case, if I were to balance my equation, then I will add up all the hydrogens, so it's C13H28. I just wrote the C13 just because that's what the question's asking for. So alkene general formula CnH2n. Okay, yes, exactly. Ryan, yes. Yeah, Osaka, Japan. Correct. Okay, if not, let's look at 35. 35 tells me that the compound C6H12 undergoes this following process. Okay, so I start with C6H12, I get ethene, and then a compound Y. So which row in the table correctly identifies process X, which is the reaction it undergoes, as well as the compound Y, which is the other compound formed in this reaction. Okay, let's try this one. This one should be quite fast. It's a bit easier than the other one. Okay, so far the votes very, very split. What I want you guys to notice here is this one you also need to take into account what is the number of carbons on both sides. Okay, please be careful about that when you're answering this question. Is it distillation? Alex, no, it's not distillation. Okay, it's about cracking. Because you have a long chain hydrocarbon turning into two smaller chain hydrocarbons. So it's cracking. So for cracking, what are the possible products formed? An alkene and an alkane. If there's any other products, the question will specifically tell you. But a regular cracking reaction is always one alkene, one alkane. But you need to check also lah. Sometimes it's different. The more important concept is your number of carbons lah. Sometimes it can be two alkenes, sometimes it can be two alkanes. You need to check the specific reaction. Okay, then let's look at this one. Let me show the results. As I mentioned just now, very, very split between A and B. Most important thing, like I said here just now, right, is the idea that the number of carbons on the left and the right must always be the same. So like I said, if you don't remember this, you'll legit get everything wrong. So here you have C6H12. First of all, it has to be cracking because you're taking a long chain hydrocarbon, turning it into two smaller chain hydrocarbons. So is it butane or is it butene? How do we solve this? We need to use the concept of the number of carbons on both sides. Okay, first question I want to ask you is, what is the formula of ethene? Okay, ethene is a 2-carbon alkene. Okay, remember from just now, two carbons, you have alkene, CnH2n, C2H4. Okay, so that's the thought process. So in this case, you have C2H4. So all you need to do from this point on, since you know on the left, you got 6 carbons, you got 12 hydrogens. On the right, you now have 2 carbons, 4 hydrogens. What's left over? You're left over with C4H8, meaning that you have 4 carbons left over and 8 hydrogens left over. Therefore, my compound Y here, this is butene, 4 carbon alkene. Answer here is B. Okay, so like I explained just now, normally it's always one alkane, one alkene. More important thing is to remember, right, that sometimes it can be 2 alkenes, sometimes it can be 2 alkanes. It's based on the number of carbons available. Okay, so answer here is B. Okay, any more questions for 35? If not, we're going to move on to our structured stuff already, which are our actual real prelim questions. Okay, like actual prelim questions. Cracking can be any hydrocarbon and the results can also vary. Yes, exactly. So at the end of the day, right, it's usually alkane, alkene, but it can always change. It's always just a hydrocarbon turning into 2 other hydrocarbons. Okay, if no other questions, let me just recap what we went through today. Later, I will show this one. If you want, you can take a screenshot here. Who was it who asked just now? Kelly, I think asked just now. You can take a screenshot and I'll do a quick recap. Okay, no worries. Okay, then let's just recap what we went through today. We covered a lot of ground today. Hopefully, you guys understand the fundamentals and now you know how to apply it to an actual topic. Okay, so we understand what's a hydrocarbon, what's a functional group, what's a homologous series. It's a family. Okay, then we talked about our alkenes, their properties, as well as their their signature reaction, which can come in 3 ways. So again, hydrogenation, bromination, and hydration. And then now, if you look back at the organic chemistry map, we know this reaction, we know this reaction, and we also know this reaction. Okay. So now that we have all the tools necessary, let's focus up. Final boss, let's try this prelim question. Okay, let's go all the way down to page number 26. So as you can see, this question 11, it has all the different concepts we went through today. Question 11 tells me, in industries, cracking is done on long chain alkanes to convert them into shorter chain alkanes and alkenes. Okay, similar to what we just talked about. So cracking was carried out on hydrocarbon C17H36 that produced ethene, pentene, and hydrocarbon X. So yeah, as you can see, a lot of you guys your school teacher do tell you only memorize until butene. Again, I recommend just memorize until 6 hept, so that it's just easier. Okay, but AI asked me to state the conditions required for cracking. So remember, what is it called? It's called catalytic cracking. So it needs a catalyst. So yeah, that's your memory work. Part 2 asked me to deduce the molecular formula of X. And part 3 asked me to distinguish between ethene and X using a lab test. Okay, so this one I will star it. This one is super important. I'll talk about it a bit more later. Okay, so I'll give everybody 5 minutes to do this. So at 4:03, I will go through. Okay, 5 minutes, guys. This is 4 marks. Okay, so this one, let's go. Time starts now. Okay, so I'll just put out a poll. And the poll is just if you're done, you can vote there. Lah. If you're done with the question. Just so I know if most people are done. Okay, if you need help, you voted for help, you can ask your question in the chat. I'll give you a hint. Hey, for those who need help, please ask your question so that I can help you. Or just let me know which part. I can give you a hint. For the last question, the test, good question, Chloe. For the last question, you want to write the actual process. So what I like to say, right, is you whenever they ask this test and observation, you want to write what you do IRL. So like literally what you actually do with your hands, or like what stuff you actually put in. Okay, so everything IRL. Brian, is it at bromine? Is a specific type of bromine? Try to be specific, Can you give the answers for the MCQ prelim questions? Yeah, can. I will send when I send the annotated copy, the answers will be there. That one you can try in your own time. Okay, about 1 more minute, I will go through. Okay, most of you are done already. Let's go through these ones. Okay, so these ones are, please make sure that you have your answer exactly the same as mine. Okay, for A part 1, state the conditions required for cracking. In this case, there's two options, aluminium oxide, catalyst, or silicon dioxide catalyst. Okay, so either one is fine. You can also write the chemical formulas or you can write the names, up to you. But you also must say 600 degrees Celsius. Okay, so this is the correct answer here. Okay, so please check part AI. This is honestly just memory work. Okay, so you need to give me both conditions to get your full marks for 1 mark here. The catalyst and the temperature. Okay, for part 2, deduce the molecular formula. What we need to do, all we need to do, right, is count the number of carbons. Here I got 17 carbons. Here I got 36 hydrogens. Okay, so if I minus away 4 carbons, 8 hydrogens, if I minus away 10 carbons, 20 hydrogens, what is my X left with? My X is actually left with C3H8. So over here, I just want you guys to be careful. They said the molecular formula. Okay, so under this prelim paper itself, right, this one is from, I think, CHIJ. They actually noted that a lot of students from that year missed out this molecular formula word, and then they went to write propane or something like that. Okay, so just be careful. When they specifically say molecular formula, please do write your molecular formula. Okay, let me see this question. For part 1, what if I write both as I... That one is fine. Yeah. If you write both. No issues. Google says that normally both catalysts are used for optimal results. You can put either one or you can put both. Either one is fine. So if you put aluminum oxide and silicon dioxide, it's fine also. Okay, but the answer key does accept, for O levels, they do accept if you put either or. Yeah, it's fine. Okay, then for part 3, the one that I start, like I explained to Chloe just now, this one's super duper important. Okay, why is it important? Because they specifically say a laboratory test. So like I said just now, you must write what you actually do IRL. You cannot write the chemical reaction that's occurring because that's not a test. Okay, so in this case, what's the answer? You want to say add aqueous bromine to each sample. Okay, so first of all, if you guys don't understand what is bromine, it's because you have ethene, which is unsaturated, alkene, and then X, which is an alkane. Okay, why is it an alkane? Because it's CnH2n plus 2. Okay, so that's why it's bromine in the first place. Okay, so for the observations, again, you want to write your observations IRL, like literally what you see in real life. So what you want to say here is, if reddish brown sample decolorizes, the sample is ethene. If reddish brown color remains, it is X. Okay, so in this case, you must add both sides. So what I mean is the positive test, you must add, the negative test, you must add. Meaning if it is ethene, it'll be this. If it is, if it decolorizes, it'll be ethene. If it doesn't decolorize, it'll be X. Okay, any questions for this? So in part 3, the test bromination. Yes. So the reaction is bromination, but for the test, you must describe what you do IRL. Why can't I write bromination? Because bromination is your reaction. Here they're asking you for your laboratory test. So literally your test itself. Do we have to write the whole sentence or we can just add write bromine? You want to say aqueous, you must specifically say aqueous bromine. So cracking is usually for alkenes. It can be for both. It's just for hydrocarbons lah. So it's either an alkane or an alkene. Okay, but just remember it is for hydrocarbons. Okay, so like I said, this is a real prelim question. It is a real prelim question. From today, you guys should be able to do this entire question. Okay, so just to finish out today, let's try one last one. Let's look at question 8. This is your last question of the day, guys. If you're able to get this, you're on the right track. Okay, so again, this is a real prelim question. So the diagram below shows unsaturated molecule A. Okay, last question, guys. Part A says name molecule A. Part B says describe a test to show that molecule A is unsaturated and the observations you expect to make. So again, whenever they say test, whenever they say observation, you want to write what you see, IRL. Okay, please be super careful about this. This is another thing where everyone always makes careless. Okay. And then for part D, try part 1 and part 2. Okay, part 3, you can leave it first. Okay, don't need to try part C, part 3. Okay, let's go part A, part B, part D. Okay, last question for the day, guys. For O levels, is writing only one catalyst acceptable? Yeah, it's fine. You can write both, you can write either. Okay, last one, guys. Don't try part 3, that one don't need to. Okay, this one should take less than 5 minutes. Let's go. Can you go through question 31 MCQ? That question is under real prelim questions. Sure. Then we'll do that after this. Okay, again, if you need help, let me know which part. You can go through both the prelim MCQs. Sure, then I'll just go through both prelim MCQs since you guys want. Okay, but I'll just, for those who cannot stay, because I just scared that you guys, I said 2 to 4. Scared you guys cannot make it. But I skip to this one. Sure, when you go NUS, then who's going to take over your class? I'll still be teaching. Don't worry. I'll always make time for you guys. I can find time. Don't worry. A minute or two more, I'll go through. Teacher, how do we find out A? That one is from, you can refer to page number 18 here. So again, you add your prefix and your suffix. So your prefix is your number of carbons. Your suffix is what kind of homologous series. So in this case, for part A is a alkene, right? With 2 carbons. So you can figure it out from here. Okay, one more minute. I'll go through. Okay, let's go through this one. Okay, part A here, like I said, it has double bond. Therefore, it's a alkene. It has 2 carbons. Therefore, it has the prefix E. Okay, so the name for this molecule is ethene. Any questions for this? Let me know. This one shouldn't be too big of an issue. For part 3, okay, that one I'll go through in a bit. Okay, for part B, describe a test. This is the exact same test as just now. So in this case, it's exactly the same as your bromine thing, but here they specifically say to show that it's unsaturated. So the only observation you need to write is showing that it's unsaturated. Okay, so what's the test? Add aqueous bromine to A. To show that it's unsaturated, the observation would be reddish brown solution turns colorless. Okay, so over here in red, I'll write the wrong ones that everyone always writes. So please be careful. Please don't write bromination. Again, this is your IRL test. What are you doing IRL? Okay, then your observation again is also IRL. So if you say bromine is added on, come on, man, this is wrong. Okay, again, this is IRL. So please, please, please always keep that in mind. It's super duper duper important. Okay, let me know if you have any questions. For part D, molecule can be obtained from crude, A can be obtained with crude oil. This one is a big hydrocarbon turning into 2 smaller hydrocarbons. This is your catalytic cracking. So just be careful. Some schools are very anal about this. Some schools are not so anal, but just to be safe, I always encourage everyone to write catalytic cracking instead of just cracking. Okay, so do just try to be safe and write catalytic cracking. For part 2, give the molecular formula of D. For D in this case, if 3 of A, which is C2H4 is here, then if you minus it away, same exact concept as just now, it will be C4H10. Okay, C4H10. Okay, for part 3 is a bit out of the scope of today's class, but I will answer your question. That's not the answer here. Your Zihao, your reactants and your product is correct. But your balancing is wrong. And it's wrong because you wrote C3H6. It's supposed to be C2H4. because it's molecule A, which is C2H4 here. So for everyone else who might not know this, combustion is when you react with oxygen and you get carbon dioxide and water. Okay, so this is a bit out of the scope of today's class. For this one, all you need to do is to balance. Okay, so you got 2 carbons on the left, so you put 2 here. And then you got 4 hydrogens on the left, so you put 2 here. And to balance it out, you put another 2 here, put a 3 here. Okay, but again, we didn't cover this today. Can I say bubble gas molecule A into bromine solution? Can also. Yeah, no worries. Chloe, that's fine. Okay, I'll leave it here to copy for a bit more. Okay, so after this, I'll be going through the MCQ prelim. But guys, I know I ran out a bit over on time. I know I was supposed to end at 4 o'clock. So for those who need to go, I will quickly give you an outro first. Again, we are Dojo. This is me. I'm chem teacher. Our schedule is as follows. Tuesday is combined chem. Sunday is pure chem. If you cannot make it for either of the classes, don't worry at all because we probably have to make a new class anyway. Okay, because the class size is growing a lot and we have a capacity of 10 students per time slot. Okay, so if you are interested in joining us, you can scan this QR code now. I'll leave it on the screen for 1 minute. And if you want to scan it, even if you're not confirmed that you want to join, if you're even a little bit interested, please scan this code. Then we can have a bit of a talk. Okay, so I'll just leave it up on the screen for a minute for those who want to scan and need to go. For part 3, yeah, that's correct, Brian. Okay, so if you want, this is just scan this to learn more about our classes. And if not, I will continue on. Okay, so if you guys are leaving now, thank you for joining us. Hope today was very, very helpful for you guys. For those who are staying, respect, you are quite hardcore. You are staying longer than most other people. Hi, can you go through the MCQ question? Yeah, I will go through. I'm just leaving this on the screen for those who have to leave first. Okay, I'll go through in like 1 or 2 minutes. Hi, Kaylin, what's up? Okay, if not, then let's go back. Okay, so whoever is still here, you are quite hardcore. You're staying longer than everyone else. Okay, so I respect you, and that's a good sign. Okay, let's look at 31. 31 for some of you guys got try already, some of you guys haven't tried. So I'll just give a bit of time for you guys to try 31. For those who try already, I'll put out the poll now. Please vote in the poll your answer. Then I can have a look. Okay, let's try 31. Let's do more MCQs. So these are 2 real prelim MCQs. Jing says, wait, bromination requires presence of UV light. No, that is you're mixing that up with your alkane reaction. Alkane, the free radical sub needs UV light, but bromination doesn't. An is 6 hours, as in 2 hours. Yes, correct. So it's a weekly class once a week. And yeah, it's either on Tuesday or Sunday, based on your whether you take pure or you take combined. Okay, I'll put a poll on YouTube also. Can you explain the UV part again? For your free radical substitution under alkanes, you need to have UV light. That's one of your conditions. Okay, but for bromination, which is the alkene reaction, there is no need for UV light. Yeah, it's just memorization of your conditions and reactants. So just memorize. Yeah, so the easiest way to memorize is using the reactions map that is at the start of the worksheet. No worries. So if I can't make it on Tuesday, can I still sign up? Yeah. So if you can't make it on Tuesday or Sunday, don't worry, because I'll probably have to start another class anyway, because yeah, we are almost full already on the capacity. So yeah, I'll settle with you guys the timing if you are interested, but cannot make it on Tuesday or Sunday. For those who want to join. Is there a crash course for English? Sadly, no. Only for the sciences, the 3 sciences, and then math. Okay, about 1 more minute, I'll go through. When you're done, please vote for this, your answer for this. Okay, for this one, what you will notice is that it is difficult. Why is it difficult? Because if you look at here, right, C4H6, this is actually technically not correct, because we normally think our alkenes is CnH2n, right? So it should be C4H8. Okay, but then here we have C4H6. So what does this mean? This is an important learning point, guys. If it's C4H6, that means actually there's more than one double bond, right? Because if there's only one double bond, it would be C4H8. So you have to realize here that we need to determine whether it is how many double bonds it has. So what you can do is a bit of maybe trial and error if you want lah. Okay, so for example, I got 4 carbons. Let's say I got 2 double bonds and 1 single bond. So let me draw out all the number of carbons here. If you notice, I got 1, 2, 3, 4, 5, 6. This is C4H6. Okay, so you got 2 double bonds. That's the important thing here. So this real prelim question section is actually for the harder questions that I could find. What you realize here, right, is that when you add hydrogen gas, what reaction is this? Of course, this is your addition reaction or hydrogenation. So your H2 gas should be added onto the double bond here. So in this case, we got 2 double bonds. So that means, right, let me draw out the ending molecule here. What you will realize is that actually we will have 4 atoms of hydrogen being added on because we got 2 double bonds. Okay, is anybody confused so far? Can you give me thumbs down? Add to both double bonds. Yes, because the reaction mechanism is that your double bond breaks and then you add hydrogen onto the double bond, right? Okay, same thing as per usual. You in each addition reaction. I just show you. For example, this one, you break the double bond and then you add the H2 onto the carbons. But we only have H2 and not H4. Exactly, that's the point. In this case, why that's the point is because now I know that my mole ratio is 1:2. Because I need to have 2H2. Yeah, so that's the tricky part here. You need to, number one, figure out that it has 2 double bonds. And second of all, realize that that means that I must have 2 hydrogen gas molecules. How you know there's 2 double bonds? Why got 2 double bonds? Because your unsaturated hydrocarbon is C4H8. If it only had 1 double bond, it would be it should be C4H8 if it only has 1 double bond. But in this case, it's C4H6. So you need to use some inference and application skills to realize that there has to be more than 1 double bond. Okay, so basically, if we cut down this formula, this equation into its actual molecular formula, it will look like this. C4H6 plus. Wait, so the hydrocarbon is an alkene? Yes, it's an alkene. Why is it an alkene? It's because they told you at the start it's an unsaturated hydrocarbon. Right, so you must remember, unsaturated hydrocarbon is always alkene. So if it's a triple bond, it'll be C4H4. Yeah, exactly. Why don't need UV light? It's just that one is just memory work. Is UV light is for your free radical substitution for alkanes. So general formula doesn't matter here. In this case, it's a special one. Like I showed you just now, right? Here, there's such thing as this thing called polyunsaturated. If it has more than 1 cc double bond, so yeah, they can have more than 1 cc double bond. But it's this is generally a more difficult question lah. Yeah. So yes, if it has more than 1 double bond, then the general formula kind of goes out the window. Then you must kind of apply it your way through. Okay, so what's the mass required to react with the hydrogen gas completely? In this case, if I know that my hydrogen gas is 0.1 mole, by mole ratio, my alkene is 0.05 mole. So here, mole equals to mass divided by mR. Okay, this is your mole concept. Your mass will be your mole times your mR. Okay, so this is how we generally do it in for Dojo. We always just remember this formula and then we rearrange. Okay, so to find the mass now, my mole is 0.05 times the mR, which is 12 plus 12 times 4 plus 6. Okay, so in this case, the answer would be 2.70 grams, which is option C. But isn't alkene general formula here? So why is it still considered alkene? Technically it's not considered an alkene anymore, but it's still an unsaturated hydrocarbon here. How do you know C4H6 is 0.05? Because the question said that 0.1 mole of hydrogen gas was used. So by mole ratio, 1:2, 0.05 mole. Yeah, just to be honest, for combined, if you're a combined student, and you were not able to get this, I wouldn't be too worried. Why not? Because this is out of your syllabus. This is definitely in your syllabus. But normally they won't test until so hard. But for pure, this is definitely realistic. How do you get 0.05 M? Again, like I said, you got the in the question it says 0.1 mole of hydrogen gas, and your mole ratio is 1:2. Sorry, what is the mole ratio 1:2? It's because the prefixes are 1 and 2 respectively. What if it's a triple bond? If it's a triple bond, they will tell you in the question. Why use the MR of C4H6 but not the single bond MR? Because they're asking for the mass of the C4H6, not for the single bond one. Any other questions? When did they say is 1 and 2? That one is what I found by doing this thing here. Why you need 2H2? Because like I explained just now, so hopefully you guys heard just now, right? My H2, because I have two double bonds, I need 2 moles of H2 to be able to supply 4 atoms of H. So this thing is technically not an alkene, technically not. It's an unsaturated hydrocarbon. Technically, it's not an alkene. Yeah, this Crystal, your question is kind of like A level kind of thing. Yeah, in the future, in A levels, if you go JC, right, you will learn more about that. But for O level, you don't really need to understand this. It's just that can have 2 or 3 double bonds. Yeah, again, if you're pure and you don't know and you didn't get this correct and you are still very confused, later I can. If you have questions, I can explain a bit more. For combine, if you don't really understand, but you weren't able to get it, but you understand, it's fine also. Okay, they normally won't really test this hard for combine. Okay, so again, they didn't say it's 1:2 mole ratio. I figured it out because I figured out that I have 2 double bonds. So to be able to react with the 2 double bonds, I need 2 moles of H2. The equation's more, yeah, exactly. Thanks, Chloe. If any questions, still please ask. But if not, let's look at 38. 38 will be our last question. Isoprene is an alkene which is commonly found in plants. What properties does it have? Okay, this is almost like a review question. It's basically reviewing a lot of things that we did. Yeah, let's try this one. This one shouldn't be too difficult. Any more questions for the 31? Can let me know. What's isoprene? It's an alkane commonly found in plants. And the question says it here. You can see. Yeah. So a lot of organic stuff, they'll just give you random compounds that you never learned before, but they'll always give you enough information that you can solve the question. Okay, for this one is a review question. If you learn alkenes in school, this should be no issue. Okay, it burns in air. This is your condensation. No, sorry. Your combustion, sorry. I just suddenly brain lagged. This is your combustion. Okay, 2, it can form condensation polymers. This one is not correct. It actually forms addition polymers. So this reaction is under your cheat sheet, under your reaction map. It is this one. Okay, so remember this is specifically addition polymerization. For those who never learned this in school or forget totally, we didn't cover this today. Okay, there's a lot more of organic chem, but as long as you understand so far, and if you want to stick with us, you confirm understand it just as well. Okay, so let me show you this. Okay, so this is addition polymer, not condensation polymer. 3, it decolorizes aqueous bromine. Correct also. So the answer here is B, 1 and 3. Okay, so this one shouldn't be as hard as the first one. Then if it's for triple bond, would it be 3H2? You mean 3 double bonds? 3 double bonds, yeah, 3H2. Why is 1 correct again? Because alkenes can undergo this reaction called combustion. Okay, so this will be in all your school notes and all our proper notes, but just for this crash course, we never went through that. Okay, but alkenes can undergo this combustion. For 31, I got that we needed 2 moles of H2 because we only had 6 hydrogens and the alkene with 10. Yeah, sure, correct. Is this correct to solve like that? It's not the best way to solve it. Technically, it's okay, correct. You will get the correct answer. But the more important thing is, I mean, the more correct way, or actually the correct way to understand it is that to break these, when I break the 2 double bonds, I have to add 4 hydrogens. So that's why I need 2 H2. Why are you suggesting what I have to remember for the whole chapter? What do you mean? Yeah, so for that one, that's not the best way to understand it. Yep. Okay, so for once again, for okay, one more time, I'll just explain for everyone still asking. For this one, the how first of all, how did I know that it has double bonds? I mean 2 double bonds. Okay, how I knew that is because they told me it's an unsaturated hydrocarbon. Okay, so this should be CC double bond. Okay, confirm there's a double bond somewhere. Unsaturated hydrocarbon. But then they tell me it's C4H6. So our regular alkene should be C4H8, right? CnH2n. So there's 2 ways to think about it. You can think about it in that between, for example, okay, I'll just explain from the ground up. Let's say we look at ethane, which is your alkane. When you go to ethene, because it forms a bond, a double bond, right? 2 carbons are gone. That's why instead of C2H6, it becomes C2H4. Then because you don't have enough space for those carbons. Okay, so once again, it changes from C2H6 to C2H4. Okay, so as you can see, whenever you add a double bond, you always lose two hydrogens. It is the first way to understand it. Every time you add a double bond, you will lose the ability to hold 2 more hydrogens. So that's one way to know that this has 2 double bonds. Okay, the other way is just trial and error, and then you just draw, and see which one is correct. Because you remember that carbon always forms 4 bonds. Okay, then after that, once I know it has 2 double bonds, how do I know the mole ratio is 1:2? Is because in this case, I need to break both double bonds. Whenever I break a double bond, I need to add H2. I need to add 2 hydrogen atoms. So if I have 2 double bonds, I need to add 4 hydrogen atoms. Okay, so that's why my mole ratio here is 2. So that I can achieve my final alkane like this. Okay. Condensation polymer. Yeah, condensation polymer is correct. Uh, I mean, it is tested for pure. That one, what's the difference? That one I cannot cover today. It's a lot of stuff. Will they give a question asking us why to explain H4 at H4? I've never seen before, lah, but it is possible as an application question, but it would be a very hard question. Lah. Okay, if not, it's already 4:45, guys, 45 minutes over schedule. If anything, can you guys please text me or WhatsApp? I'm open to any questions about anything. Let me just show you this. Yeah, once again, this is the QR code. If you guys are interested at all, again, it is Tuesday 7 to 9 for combined, Sunday 7 to 9 for pure. Yeah, so if you want to, you can scan the QR code. What are you covering right now in your weekly class? For pure, we just did more concept revision, moving on to electrolysis revision. For combined, we we have finished more concept also. Same thing. Yeah. Okay, thanks for the question. No worries. Okay, so once again, if you guys want to, please scan the QR code. And yeah, no worries, Sean. You guys don't offer for AMF. Sadly, no. Currently, this is the only schedule. It's only pure, Chem, EMF, Physics, English. Yeah, I'll send this QR code also later. If it's not working, I'm not sure. Yeah, any questions about it, please just text me on WhatsApp and then I will reply you guys. Okay, so if you guys need to go, you guys can leave. Now I'll just stay here, answer questions about the classes. Okay, thanks. All the best, guys. So just to know, because it has double bond. Yeah, correct. Just because, yeah, it has double bonds, so you must add H2 to both the double bonds. Are you coming to JE station? Yeah, we'll be coming. So I will update the Telegram channel with all the schedules and stuff. Is it too late to join your classes now? No, definitely not. Okay, we still got 4 more months at the O levels. Actually, it's quite little, but in 4 months you can change a lot. All right, thank you so much. No worries. No worries, Osaka, Japan. No worries, guys. Yeah, if you have any questions about chem and stuff or how our classes can help you, you can text me on WhatsApp. I'm the guy who texts you guys everything on the group chat. Can leave now. Yes, can leave now. I'm just staying here for those who need questions. I'm just chilling. Bye bye. Bye guys. Okay, guys, if any more classes, if any more questions, you can text me on WhatsApp. Okay, I'll stay for one more for YouTube.